Okay. So we have already understood all the example problems, all the theory related to trusses. Now let's solve all the gate numericals. So there are three numericals which are asked in aerospace. There are other examples also, which from mechanical, civil, I will try to create in your materials and in your test series portal. So we have one numerical asked in 2019. This is asked for 2 marks. We'll do it together. This is, if you see, in 2019, they ask us to calculate when the truss fails due to buckling. So I don't know how many of you remember the theory of columns, but please take it as a truss problem. In the end, we'll try to relate it with buckling of columns. I'll give you the formula. Once you know column, it will be easy for you to relate this. But you definitely know it's a truss, right? It is made up of 3 members. A P load is acting. Let's read the numerical. All the bars in the given truss are elastic with Young's modulus equals to this. So they have given us Young's modulus and have identical cross sections with moment of inertia of this. So they have given area moment of inertia. Now the question says, what is the lowest value of the load P at which the truss fails due to buckling? Now you know a column is one which buckles under compressive load. So if you have any kind of column, right? Any kind of column, it will only buckle when you apply some critical load to it. And that is nothing but Euler's theory of buckling. For columns, we need to study this. So I'm assuming that this is needed later and you know this. If not, it's fine. I'll try to cover this part. So what we're going to do is, you people always know the first thing in a truss, always a good idea is to first calculate the reactions. Correct? Let's quickly calculate the reactions, but I can verbally do this in this numerical. Why? See, at reaction at point B will be 1 vertical and 1 horizontal, and there will be 1 reaction at point C. Correct? Now, if you see R horizontal, there is nothing. Why? There is no external force acting on the system, right? When someone tries to push it, then only reactions comes into picture, right? So reaction at point B in horizontal direction is already gone. I don't have it. I don't need it. It is not present actually. So the only reactions I have are 2 vertical reactions. And now I'm not doing these calculations. I hope you people understand and follow this. This is a symmetric structure, guys. So when a load P is applied, it has to be balanced equally by both the people. So if you don't like this, you can definitely use equilibrium equations, which I have already solved in the previous lecture, in the previous video before. RBV, which is a reaction at B in vertical direction, is exactly equals to reaction at point C, and it is equals to P by 2. I hope you people agree on this without doing calculations how I have written this. Once you know the reactions, now my motive is to calculate forces in each truss member. Because we need to calculate lowest value of P, you will come to know that I want to see all these are 3 members. So in all these 3 members, if you people agree, because it's a symmetric structure, right? Whatever force we have in AB, same force will be present in AC because it is very mirror image, right? But we need to solve separately for BC. These are separate. Now let's start this if it is possible. I'm going to, let's say, joint A. Again, it's not a rule. You can go to any joint. You can go to joint B also if you like. Let's go to joint B if it is fine. So at B, if you people agree, there is a reaction force here, which is P by 2. This one, RBV. There is no horizontal force. I'm not drawing this. And there will be a force, which I'll say force of member BC. And there will be a force, sorry, there's no vertical force. There will be a force, which I'll say AB. And this is at an angle of 45. Now we have 2 unknowns. We know this. We have 2 equilibrium equations, right? I'll resolve this in X direction. I'll resolve this in Y direction, and my numerical is over. Let's resolve this in X direction first. So what we got in this, FAB cos 45, it is going in the right direction. If you resolve this component, 1 in X and 1 in Y, so cos and sine, plus F of BC goes to 0. Both of these things you don't know. You don't know FBC, you don't know FAB. Now let's try out this in vertical. If you go in vertical, you directly have FAB. Correct, right? Yeah, true. F of AB sine 45, which is going up. FBC will not come here because it is pure horizontal. Plus P by 2 goes to 0. This is my equilibrium equation in vertical direction. If you see, I'm talking about this. It is FAB, vertical component will be FAB sine 45. Going up, so I'll say plus. This P by 2 is going up, so I'll say plus. And if you solve this, force in AB, truss member, is nothing but minus P by 2 divided by sine 45. You know what sine 45 is? This is 1 by root 2. Once you substitute this, you'll get this as minus P divided by root 2. I hope everyone follows this. Minus P divided by root 2. So I got force in AB. If you really like, you can calculate it in BC also, if it is needed. All right, I think I have, let me do it here only, guys. Anyhow, you people have written this, right? I don't want to change slide for this. I'll go for the last step. Just substitute, you need to calculate this. So FAB, I'll substitute here. What is FAB? Minus P divided by root 2. What is cos 45? 1 by root 2. And this is plus FBC and it goes to 0. So what is FBC, guys? Force in BC member. This goes to the other side. Root 2 into root 2 is 1. So this is P by 2. Although it is not needed, but still I have calculated this. So now the question says, what is the lowest value at which the truss fails? Now, truss can fail at this, any one member fails, my truss fails, right? They're asking what is the lowest value of P. And I hope you people agree that lowest value will come from which expression? From this expression. AB will fail quickly. It's critical load. Now, if you don't understand this, it's perfectly fine. What I'm trying to tell you is I'm going to next slide. So what you understood now is that there is a truss member, which you name it as AB. And this truss member, if you people see, AB is experiencing minus P by 2. What is this minus? Compressive load. But if you go to BC, it is experiencing plus P by 2, right? Means BC, if you people agree, is a member which is being pulled outside. This will never buckle, right? Problem is buckling means compressive loads. So if you see AB, this is the problem, and something like this is happening. You are compressing it with force of P by root 2. That's what you have calculated. I just want you to understand the physical problem. So why I am not considering F of BC, I hope it is clear. So I'm going directly with AB. Now from here, slight column theory is needed. If it is clear, it's fine. Otherwise, please try to get this. All these are joints, right? These are pin joints. This is pin joint here. This is pin joint here. And in columns, if you have pin condition, right? This is, I'm just carrying forward. It is perfectly fine. It is perfectly fine. Why F of AB is this? What is sine 45? 1 by root 2, right? What is root 2 and 2? It is perfect. Just check your calculations, please. So this is pin configuration. And for a column under pin configuration, the critical load is given as pi square EI divided by L square. That's the critical load condition. If you want to, what is critical load at which the column fails? Now, if you substitute your number here, what is critical load for us in this column? That is P divided by root 2. That's what the load is being applied to this column. Pi square, I hope it is fine. E for this numerical, if you see, this is Young's modulus. I will do all my calculations in Newton, guys, because in the end, they're asking kilonewton. I'll convert it later. So if it is 200 GPa, I'll write this as 200 into 10 to the power 9. This is pascals now, that is Newton per meter square. Then I is moment of inertia and have identical cross section with moment of inertia of this, which is moment of inertia. All the bars in the given truss are having this and have identical cross sections with moment of inertia of this. So you have moment of inertia, which is provided to you as 0.1. And this is given in centimeter to the power 4, guys. All right, so you need to convert this into mm, or if you like, you can convert this into meters, depending upon the units you need to play. If you want to convert everything into make sure, yeah. So then okay, it's fine. If you want everything in then E should be taken in megapascals. This is, I want everyone to have a clear understanding. 200 gigapascals, meaning pascals is meter square. So if you multiply this with 10 to the power 3, this becomes megapascal. And I hope you people know megapascal is nothing but Newton per mm square. This is one and the same thing. So when you're writing 200 into 10 to the power 3, you're writing this forces in Newton and lengths in mm. Now, if you see your moment of inertia is given as 0.1 centimeter to the power 4. So I will convert centimeter into now, and 4 centimeter, like centimeter into is multiplied with 10 to the power 4 divided by, now this is the problem. I have seen people doing this last step mistake in the exams. I need this member length because you're solving for member AB, right? And people quickly use this as 10 centimeter. No, I hope you people agree. This is not 10. If this whole is 10, half of this is 5. Correct? This angle is 45. So this is 5. So I hope you people agree that using Pythagoras theorem, 5 square plus 5 square. Yes. Correct. So this is nothing but 5 root 2. This length AB. Guys, I've simply applied Pythagoras theorem. This is 5, this is 5, because this angle was 45. So I've simply applied Pythagoras theorem and this came out to be 5 root 2. And now you substitute here 5 root 2 whole square. Again, you will do mistake that these lengths are given in centimeters. Please don't forget to convert this into So I will convert this by multiplying by 10. Solve this, multiply this P to the other end. I'm waiting for your response. You should get this as 558,309.16 Newton. This is in Newtons. Don't forget, don't worry, you can do your calculations later. The intent is to make you understand about the concept. But always in GATE numericals, make sure what they're asking. They're asking us to calculate buckling load in kilonewtons, and they ask me to put this in nearest integer. So never put these values in points. I will substitute my answer as kilonewtons, which is 558 kilonewtons. I'm not writing any points, guys, because they asked me to put this in integers. Always make sure you do this when it is fill in the blank numerical. And if I'll say official key, right? Official key is 550 to 570 kilonewtons. So this is the perfect answer, which is lying inside the range. This is asked in 2019. I'm waiting for a few seconds. If you have any doubt, please let me know, guys. Otherwise, I'll go to next GATE numerical. Is it clear? Can anyone verify the values? We're getting the same number, right? We're getting the same value, right? Anyone has anyone who can? So Ravi, you have done the calculations, right? All numbers calculations, because if there is any typo, please let me know. I don't want people to have typo, because my main intent is to make you understand the concept. If plus minus multiplied divide 10 15 some points I'm missing, please let me know, because I don't know, sir. Okay, it's good, right? So I hope I have done the unit conversions also properly here. I have not missed any unit conversions here. Perfect. Okay, perfect. I'll go to next numerical, guys. Now this is asked in 2022, very latest. And this is only asked for 1 mark. Now, this is very easy for you people to solve this because you people have already solved many examples, right? In the previous lecture, it's very easy for you. There is a 3-member truss, which is simply supported at Q and R. You know what is simply support? One hinge, one roller. And loaded at P by a horizontal force F as shown. And what we need to calculate? The force in QR. So we need to calculate force in this member only. That's it, nothing else. You people know what first we do. First, we always calculate what? I prefer to calculate external forces. External forces means I want to calculate reactions always. Let's calculate these reactions. So there is a reaction at point Q in vertical. There is a reaction at point Q in horizontal. There is a reaction at point R in vertical direction only because that is roller support. So I'll apply RQH, which is horizontal reaction, plus force is also going in this direction. So I'll equate it to 0. So what reaction I got? Reaction at Q in horizontal direction is nothing but equals to minus F. Minus means what? Whatever we have assumed, please go in the other direction. It's fine. Let's calculate the vertical forces now. So vertical force at Q plus vertical reaction at R, and there is no external force, guys, to stop it. So meaning I simply got one relation that these reactions are same, but with opposite magnitudes. But still I don't get the solution, right? So I apply third equation. What is third equation, guys? I take moment about a point. So I'll take moment about a point Q, which I feel is easy for me. So if you take moment about point Q, this reaction and this reaction will create 0 moments. So the only moment will be created by this reaction R, force into perpendicular distance. Let's say this length is something. I'm not interested. Let's say length is QR. And this is exactly balanced by this force multiplied by this distance. Force into perpendicular distance. Correct, right? Which length is PQ. Now, if you people agree, this QR and PQ are length are same. Why? If you see, they have given angle as 45, right? This is an isosceles triangle. So this side is exactly equals to this side. So this and this got cancelled out. And I got reaction at R as equals to F, which is also equals to my reaction at point V, but in the opposite direction, which we got from this relation. So I know this looks maybe this is very simple. Actually, you people know this, but I don't want, you can actually in videos, you can go forward, right? And you can directly go to the values. So what I want to do now is I want to draw an equilibrium diagram for this. So I'm drawing the same truss again, and I hope you people will like this. So these are the points Q, this was P, this is R. At this point P, there is a force F. That's what it is given in the numerical. At point Q, if you see, there is only one horizontal force. Vertical force is also present and it is going down. If you see, both horizontal and vertical came out to be negative, right? We have assumed these when we have solved it. So now I'm just putting it with opposite sign. So I have at point Q, vertical force in this direction. I hope you people agree. Horizontal force is minus F. So I'll simply say F now. I have reversed the direction. Similarly, at R, my force is F. Positive means what I have assumed is correct. So there is a reaction force here, F. And at Q, it is F again with a negative sign. So this becomes my actual diagram, which was this truss. Just I have marked the reactions. Guys, why I have reversed the direction? I assume this when I did my calculations. When I get my answer negative, I simply reverse the direction and write the magnitude. Now, once you have this, don't forget your final expression. You need to calculate force in QR. So in this vector. So with joint, I think this is very easy. I can directly go to joint Q if you like. You can go to joint R if you like. Any joint. Let's say I'll go to joint Q. Maybe if you like, you can go to joint R also. It's both are one and the same thing. So if you go to joint Q, You have a force here F, you have a force here F, you have a force here going upwards, and I'll say this as force in PQ, and you have a force here in QR. This is very straightforward, guys. This numerical is over. Or there is no components also, right? This FQR has to balance this force, then only body is in equilibrium, right? So I can directly say force in QR is nothing but equals to F, which is my final expression. It came out to be positive, right? So this is F tensile. I hope I'm clear in this. If you people don't like this, definitely you can go with R. Again, you will get same value, and you should get this as F with positive sign, meaning this is tensile. So this is force F is tensile and the magnitude is F. Please tell me if this part is clear to all of you, and we'll go to the next numerical, which is asked in your GATE exam related to trusses. Perfect. Good. I'll go to the next numerical. If you see, guys, trusses itself, this is asked for 1 mark in 2022. And now this is asked for 2 marks in 2022. So lately, they're asking trusses in your GATE exam. Last year itself, 2022 was asked for 3 marks, a small topic for 3 marks, a very straightforward topic. Now, if you see, you will understand this. Don't deviate from truss concepts. And maybe I'll explain you a few concepts which you should always know from your basic elasticity equations. If you have done basic elasticity, you will understand this. If not, try to take this as a theory. So there is an horizontal load F applied at point R. So if you see, there is a load F, which is applied at this point on a 2-member truss as shown in the figure. Both the members are prismatic with cross-sectional area A0 and made up of same materials with this. I will later come to this. The horizontal displacement of point R is, so what they are simply saying is there is a truss member like this. At point R, you are applying a force F. What is horizontal displacement? So when anything like this comes in my GATE exam, right, always make sure that you see a truss, don't start solving for forces. No. First of all, you think that whether you know how to solve this numerical or not. Otherwise, there is no point of calculating forces, wasting your 2, 3, 4 minutes and then leaving the numerical because you don't know how to calculate displacement. You know how to calculate forces up till now. So whenever we want to calculate displacement or deflection, we can go for multiple methods. I prefer Castigliano theorem in this. Why? Castigliano theorem simply says, I'm writing this word here, Castigliano theorem. Sorry, my bad. Yeah, Castig. This theorem simply says, if you know your strain energy, and if you differentiate your strain energy with respect to load acting at that point, you will get the corresponding deflection at that point. Now, if you see, you have a load acting at point R in horizontal direction. So if you calculate strain energy of the system, and then you differentiate the strain energy with respect to this load, you will get the corresponding deflection. I again repeat my statement. You will, if you differentiate strain energy with respect to a load acting at that point, it will give you the deflection at that point. That is what is known as Castigliano theorem. Meaning, if I want to calculate deflection at point R, I just need strain energy of this system. Now, the problem is how we will calculate strain energy. This system has 2 rods, PR and QR. Correct? So if I want to calculate its strain energy, I'd expect that you people don't know this. So I am not giving you theory only for trusses. I'm giving you the basics also. Strain energy is represented as capital U. Don't forget this. Capital U is strain energy. If anywhere you find small u, this is known as strain energy density. So there is a difference. Density, you have already divided this with volume. Then we got, so if you divide strain energy with volume, you will get small u, which is known as strain energy density. Again, this is more detailed theory of basic elasticity. I'm not going in this lecture into detailed part of it. But I want you to tell strain energy is the energy stored inside the system, and system has 2 rods, U, PR, strain energy of PR, and U of QR. If I can calculate strain energy of these 2 bars, I have total strain energy. Once I have total strain energy, I'll differentiate it with respect to F and I'll get the corresponding deflection using Castigliano theorem. Now the question is, do I know how to calculate strain energy of any bar or a rod? All right. So I'm just telling you, although this is not scope of this lecture, but still, if you have any rod which is pulled by certain force P, what is the strain energy in this section? Let's say it is made up of certain area, it is made up of certain Young's modulus material. So strain energy, if you people see, right, is simply this load versus deflection graph. Yes, I am just deriving that formula, Prince. So if you calculate area under load versus deflection graph, right, this represents strain energy. So how to calculate area under this rectangle? Half base into height. Correct? Area of triangle. And this delta is nothing but change in length. Now I'm doing this in rough. I assume that you people follow this. Many of you already know. I know many of you already know that strain energy for axial system is P square L by 2 AE. I'm just deriving it because I don't want you people to have a confusion. Once you know everything, you should know this basic also. So what is this delta, guys? If you people agree, this delta is nothing but change in length, right? Deflection. So change in length divided by original length is nothing but known as strain. So if you see this delta L, which is written here, same thing, deflections. This delta L is nothing but strain into length. And what is strain, guys? You know Hooke's law, right? Stress is directly proportional to strain and Young's modulus comes into picture. That is nothing but stress divided by E. So change in length can also be written as stress divided by E into length. And what is stress? Stress is force by area, right? So force is P, area is A. So we got change in length as PL by AE, which if you substitute here, you will get simply as P square L divided by 2AE. I definitely expect you people to know this when you're going in your GATE exam. You can't afford to do these derivations for axial loads, for bending. For bending, it is M square. If you people recall, M square dx divided by 2EI integration, we can calculate strain energy and then we can use it, Castellano theorem, to calculate deflection of beams. Same thing, you can do this in torsion also. Yes, you can do this in torsion to calculate angular deflections, d theta by dz, or you can calculate directly theta also, which is twist angle. I hope this is clear that this is the strain energy of any axial system, P square L by 2AE. Now my motive is you want to calculate for PR and you want to calculate for QR. For this, I need load acting here, right? So I will calculate force in this. I'll calculate force in this. It will not be same, guys, because there are two different, there is a force F. So what I'll do is, I hope you people agree, I'll go to joint R. Okay, let me do it here. Let me do it here. Once you go to joint R, what forces you expect here? There's one force F, which is going like this. PQ doesn't have any strain energy. It's a fixed system, right? This is fixed. This is maybe made up of concrete and all. That is not a system which will going to fail. There are horizontal load applied to two-member truss. PQ strain energy will not be considered. All right. So there is one force F acting here. So one doubt came that why we are not considering strain energy of PQ, because PQ is not a truss member, right? Then there is a force PR. There is a force PR. And then there is a force QR. And you know the angles. This is at an angle of 45, right? So if this angle is 45, this horizontal one is also 45. So I'll simply mark the angles if it is fine. This angle is 45. This angle is 45. Let's quickly calculate the forces, guys. So I'll do these equilibrium in vertical direction first. So if you see, this force will be resolved in vertical direction. This force will be resolved in vertical direction. So I'm simply doing this. All the forces in y direction should go to 0. So I have force in PR truss member sine 45 plus force in QR truss member sine 45, and they both go to 0. I hope it is very easy. This and this got cancelled out. And what we got, that whatever force you have in PR truss member is exactly same, but it is in the opposite sense. So one is in tensile, the other one should be in compression. That's how the system behaves. I'll do the next equilibrium now. What are forces in X direction? Let's resolve this. FPR cos 45. Why I put a negative sign? Let's say it goes in the negative direction, plus FQR, sorry, again cos 45, because it is going in right direction, plus there is a force acting here, and they all should sum up to 0 because the body should be in equilibrium. Correct? But just now we have proved that this FPR is equals to minus of FQR, right? So if I'll substitute here, guys, please follow this if you people agree on this. Can I write this term as, just understand this, FPR I'm writing as minus of FQR. Correct? Minus minus becomes positive. I hope you people agree on this. If it is not, guys, this is fine, right? So I'm writing this as 2 FPR cos 45 equals to F. I hope it is clear. I've just substituted this value. I've substituted, to be very precise, FQR as minus FPR and send the other terms to other side, cos 45. So if you now calculate force in one truss member, it came out to be F divided by 2 divided by cos 45. And you know what cos 45? It is 1 by root 2, right? This root 2 and this got cancelled out. So you get this as F divided by root 2. And this is also force in QR, but with a negative sign. So I've calculated forces in both the truss members. And these forces will act axially to these members, one member here and one member here. And what we need to calculate, once I have force, I will calculate strain energy corresponding to that. Let's do it step by step. So the force came out to be F divided by root 2 in PR and minus F divided by root 2 in QR. That's what we got. Let's calculate strain energy now. All right, I'll do it here only because I think this part is clear for all. All right. So what is total strain energy, guys? Total strain energy is stored in both the bars. And each bar formula is P square L divided by 2AE. P is the load acting on that particular bar. So first load acting is load acting in PR whole square into length. Now this is the catchy part. Okay, let me just keep it into AE plus force acting in QR square L divided by 2AE. Now the mistake you people do is, first of all, area and E is fine. A naught is the area and modulus is E. So rather than A naught, I'm writing A naught. Area of both the bars is same. But guys, this L should not be written here. Why? If you see, I need length of this bar. Length of this bar is this, right? And I don't know how many of you agree on this. If this is L, and if you see this angle is 45, this is also L. What will be this length, guys? I hope you people understand and agree that using Pythagoras theorem, it will be root 2L. Guys, what I'm saying is simple Pythagoras theorem. If you want to calculate this length, this is L. This angle is 45. So this is also L, isosceles triangle. Then using Pythagoras theorem, this is root 2L. Don't forget that you're calculating strain energy for this bar, PR. So force acting in PR, which is P. Length of that section, which is not capital L. So I'm writing it now here. Force acting in PR. Length of this is root 2L divided by area given is A naught E plus force acting in QR whole square. Length is root 2L divided by 2A naught into E. Now forces we have already calculated. It came out to be F by root 2, positive and negative. But luckily we have a square here. So everything is fine. Plus minus won't change my solutions. So when you substitute it here, what this becomes, don't forget, your force was F by root 2. Square of it will be F square by 2. This already have root 2L. This already have 2A naught E plus this is again F square by 2. This already have root 2L. This already have 2A naught E. And this is my strain energy. So if you add, I hope you people agree on this. Correct, right? Guys, this is fine, right? For everyone? Correct, right? Yes. So I have my total strain energy and I hope this is exactly same. So final expression came out to be root 2 F square L divided by 2A naught E. You see, you can add these two quantities, right? This plus this. So 1, 2 got cancelled out. Guys, this is very straightforward. Please try out this. If you have confusion, then definitely please let me know. We can answer this. This is nothing but this plus this. So you'll get 2 outside and 2, and in denominator, I have cancelled out 2. I got this. Now, what is the last step? Differentiate your strain energy with respect to load in that direction. So when you differentiate your strain energy with respect to load in that direction, you will get the corresponding deflection in that direction. So if you differentiate this, this becomes root 2 derivative of F is 2F into L divided by 2 into A naught E. This 2 and this 2 got cancelled out. So deflection of R is nothing but root 2 times F into L divided by A naught E. We got the expression, which is actually one of the option. If you can clearly see option C, which is root 2 F into L divided by A naught E. It looks like a truss problem, but believe me, every truss is made up of an axial load carrying system, which we name it as bar or a rod. And bar or a rod, all equations. How to calculate stresses? Force by area. How to calculate strains? Change in length divided by original length. How to calculate strain energy? P square L by AE. Every basic is considered here. Why it is considered as a truss problem? Because it was a truss. And before solving and calculating this, you need these forces. Which, if you know forces acting in each member, then only you can apply these concepts and get the solution. Castigliano theorem, if you see this, we usually cover in bending, but it's a very generalized theorem, right? If you differentiate strain energy in any direction with respect to load, you will get deflection in that direction at that particular point. I hope this point is clear and it's fine, guys. Please let me know if you have any doubts. And please try to cover basic elasticity before and some columns theory before finishing this topic.